Dear students, now we are going to continue the last lecture, which is lecture 5, and we are going to start with lecture 6. In this lecture, we are going to continue with the next sections, 5.2, Present Value. Chapter 5.2, Present Value. In chapter 5.1, we have discussed about the compound amount S given by S equal to P multiplied with 1 plus R over K to the power of KT. We know that S is the compound amount, and we call compound amounts also as the future value. And P is the principal, and we call principal also as the present value. So what is the present value? Present value is the principal P that must be invested for T years at the rate of R compounded K times a year, so that the compound amount is S is given by P equal to S divided by 1 plus R over K to the power of KT. So this is only a simple calculation. So when S equal to P multiplied with 1 plus R over K to the power of KT, automatically P is equal to S divided by 1 plus R over K to the power of KT. So this formula can be written also as P equal to S multiplied with 1 plus R over K to the power minus or negative KT. So P is the present value. Example 1. Present value. Find the present value of $1,000 due after 3 years if the interest rate is 9% compounded monthly. From the problems here, we get information of the future value that due after 3 years, which is $1,000. So it means S equal to 1,000. And after 3 years, meaning T equal to 3, and the interest rate of 9%, so means R equal to 0.09, compounded monthly, K equal to 12. So the question here, find the present value. What is P? So we are going to use the formula that we discussed previously. So P is equal to S multiplied with 1 plus R over K to the degree of negative KT. We substitute all the information of the variables that we have here S, T, R, and K. So P equal to 1000 multiplied with 1 plus 0.09 divided by 12 to the degree of minus 12 multiplied with 3. So now P is equal to 1000 multiplied with 1.0075 that we get from 1 plus 0.09 divided by 12 to the degree of minus 36. So minus 36 we get from 12 multiplied with 3. So we will have the result is about 764.15. So it means the amount of about $764.15 must be invested at 9% compounded monthly to have $1,000 in 3 years. Example 2. Single Payment Trust Fund. A trust fund for a child's education is being set up by a single payment so that at the end of 15 years, there will be $50,000. If the fund earns interest at the rate of 7% compounded semi-annually, how much money should be paid into the fund? From these problems, we get the information about the future value. There will be $50,000. It means S is equal to 50,000. After 15 years, at the end of 15 years, it means T equal to 15. Interest rate at 7%. It means R equal to 7% equal to 0.07. Compounded semi-annually means K equal to 2. The question here is how much money should be paid into the funds. It means the present value, which is P. Now we are going to use the formula of present value. P is equal to S multiplied with 1 plus R over K to the power of minus KT. We substitute all the value of the variable S, T, R, and K into the formula. So the formula becomes P is equal to 50,000 multiplied with 1 plus 0.07 divided by 2 to the degree of minus 2 multiplied with 15. So 1 plus 0.07 divided by 2 become 1.035 and 2 multiplied with 15 become 30. So the formula become P is equal to 50,000 multiplied with 1.035 to the degree of minus 30. So we get the result here is about 17,813.92. So the amount of money should be paid into the fund is about $17,813.92. So this amount should be paid into the fund at 7% compounded semi-annually to have $50,000 in 15 years.